All right, let's continue 3.3. But we'll focus on synthetic division. Okay, and then let me also pull up the book. We might need a. We may need it. One sec. Here. So remember, you can use this or long division. Use synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 4. So what you do is you create a little bar like this to keep us in order. Now, you start with the highest power. All the coefficients go in order. So the coefficient of the x to the fourth is a 1. Notice how there is no cubic term, right? It goes 4, 2, 1, 0. This is a 0 power. First power, second. No 0, no third power. So you put a 0 for the third, and then the coefficient for the quadratic, for the x term, and for the constant. Now, what you're going to divide by this guy right here, the x plus 4. So what you do is put, actually it should be plus 3. So put the 3 right here. Okay. So bring down the 1. This is how the pattern starts. You bring the first constant down, and then you do -3 times 1. And then you add it up. 0 plus a -3. -3 times -3. -3 times -1. So okay, one more time. Let's go over this again. Bring the 1 down. -3 times 1 is -3. 0 plus -3 is -3. And then you go over here. -3 times -3 is 9. -10 plus 9 is -1. -3 times -1 is 3. -2 plus 3 is 1. And -3 times 1, -3. 4 plus -3 is a 1. Do you see the algorithm? Do you see the pattern? So always, I'm sorry. Any questions on this step here?
So I guess it's not a 0 because it doesn't end in a 0.
Correct. This will be our remainder. So right here, this is my remainder of 1. So essentially what we did is this. So this divided by this is equal to, and then you take these coefficients right here and create the new polynomial. So the result is going to be this. So this is going to be reduced by a power of 1. So this was a fourth power. This would be a cubic power. Okay. So the 1 the -3, the -1, the 1. And then plus your remainder. But remember, you always write the remainder as whatever it is over the divisor. So see, this is much easier than long division, right? Any questions on the first example? Okay. So another cool thing about this is you can use the remainder theorem to figure out what the function of value is by whatever you decide to divide by. So basically, if a polynomial f of x is divided by x minus k, then the remainder is r equal to f of k. Now, in plain English, what this means is if I plug in -3, if I plug in the opposite of this value here, so see how we were dividing by x plus 3, right? So if I plug in -3 into this function for every x, you will get a 1. So this 1 is the same as inputting this value. That's what this is saying. So instead of plugging it in, I can just do this divisor thing. So this is called the remainder theorem here. Okay. So in the homework, they might ask you, you know what, evaluate this at x equals to -2. Evaluate f of x of 3x cubed plus 8x squared plus 5x minus 7 at x equals -2. So what that means is you're going to divide by -2 and see what the result is.
And we can't see the bottom of your paper.
Oh, thanks. So 3, 2, 1, 0. We got make sure you have all the powers before we start writing them. We have all of them. So 3, 8, 5, -7, right? So you could just plug this in right here. That would be the answer. But they want you to see that if you divide by this, that's the same thing as plugging it in. So bring this 3 down. -2 times 3. Oops. Stray mark. -2 times 3 is a -6. 8 minus 6 is a 2. -2 times 2 is -4. 5 minus 4 is 1. -2 times 1 is -2. -7 minus 2 is -9. So what this is saying is that f of -2, which would be 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7 is equal to 9. This 9. These are the same. Does the remainder theorem make sense? That's what it does.
So I guess the remainder is the y.
Yeah. Yeah, and the remainder is same as the output of the function, the y value. So R is also this. That's pretty cool, right?
Yeah.
So this becomes handy when we're trying to find zeros, because if we know when it's equal to 0, then we can use that to factor and reduce high powers, because we know a bunch of techniques for quadratics, right? But we don't have that many for cubics, 4th, 5th, 6th, 7th powered functions. So what you can do is long division to factor it into many pieces, and then you can find all the zeros. So as long as you know what to divide by, you'll be able to factor it piece by piece. Okay. So at the beginning on the homework section, let's go ahead and look at the homework. Maybe make sure I change the settings before we move on. There we go. I must have not hit save last time. There we go. So now I should let you do one question at a time. All right, so share screen. All right. So the first few questions are just going to be, all right, use synthetic division, divide by this. So you set it up like we just did. Right, no big deal, these two. That's exactly what we just did. And then eventually, let's see if I give you anything interesting here. Let me delete that guy. That guy looks stupid. Let's do one more synthetic before we do that one. Let's do, I don't know, 16, I guess. All right, 6, example 3, problem 16. I'm just going to put divide. Technically, this is divided with the synthetic, but who cares? That should be apparent. Okay, so I'm dividing by this. So note that this is the same as saying x plus 2 divided by this, right? So you could do long division if you wanted to, but we don't want to. So if it's x plus 2, remember that you're going to use the negative, the opposite. If this was minus 2, you would have a plus 2 here. And then you look at your powers. I have a 3 and a 1 and a 0. I don't have the second power. So remember to add a 0 for cubic, square, constant. I'm sorry, linear and constant. So 0 for the quadratic. Bring down the 3, negative 2 times 3. 0 is that. So bring the 3 down as the first step. Negative 2 times 3 is the negative 6. 0 plus negative 6 is negative 6. So when you're going this way, it's always addition. And then once you've added it, you go back to the multiplication. Negative 2 times negative 6 is a positive 12. 6 plus 12, 18. Negative 2 times 18. That's negative what? that 36? 8 minus 36. Negative 20, 28, right? Thanks. Okay. So we did the division. So that means that 3x cubed plus 6x plus 8 divided by x plus 2 is equal to, so just remember that whatever you started with, reduce the power by 1. So cubic, the answer will be quadratic because I divided by a linear, so it should have lost 1 power, right? 3x squared minus 6x plus 18, and then the remainder over the divisor. Any questions on number 3? Excuse me. Okay. So if they tell you, if they write it this way, obviously that means you're dividing by x minus 6. So you would use positive 6, right? X plus 2, we just did that. You divide it by negative 2 on the synthetic. X minus 4, that means you divide by 4. If they write it this way, you just put a minus half. If they tell you straight up what the k is, that's what you're going to use your, that's going to be your synthetic divisor part, okay? So you would have your bar, and then you would have 3 here. So this is always oops. This is always your k.
What does the K mean?
What's that?
Like, does it mean X or I guess
K is this number here that's going in, that you plug in, or you're going to use as your synthetic divisor.
So when you're plugging in for K or using the number for K, it's never going to change. It's never going to go like that one for like number 3. It's never going to go from positive to negative. It's just
Yeah. So yeah, in this case, k is -2. Over here, k is 6. Does that make sense?
yeah.
But
But
if they-
like on that
if they-
on that other one where K equals 3, it's not going to change to -3, right? When it gives it to you.
Yeah, exactly. So if it's given, then that's what it is.
Okay.
When you choose the k, that's when you may have to switch it, right? Because k is based on the opposite of what that factor is down here. Okay,
Can we do 21?
21. Let's see. 21 sucks. I'm gonna delete that one. Let's not do that.
Okay, thank you.
Neither one of us. 21 and 22 is the same thing, but the numbers are prettier. So let's do this one because it'll make more sense. That other one is just annoying. It's doable, but it's gonna take like 2 pages. Okay. Well, this one's kind of long too, so let's go ahead and turn the page just in case. Okay, so I'm gonna write you a note. If f of k is equal to 0, then x minus k is a factor of f of x. Okay. That's what we're going to use for this guy. I'm going to shorten up the question. Factor f of x. I'm going to rewrite it too, just so it's clear. So factor this guy given that x equal to -3 is a 0. So we know that this is going to have no remainder. Start straight up from the beginning. We will know this. We have 3, 2, 1, 0, so we don't have to write any zeros. It's 1, 6, 11, 6. Okay. Bring down the 1. -3 times 1. Add these up. 3, -3 times 3. Add those up. Should be negative. -3 times 2 is a negative. There's my 0. So we said that if k is 0, then I can x minus k is a factor. So when you get a 0, what you can do is rewrite the original. Equal to this piece. So it's going to be a squared type times the divisor that I used. So if you're factoring, remember we said if it's a 0, x minus the k is a factor. So if k is -3, minus minus would be the factor, which is of course +3. So you see how we are able to factor a cubic using this technique. That's why it's pretty handy, because we can now deal with high-powered functions.
I have something to say.
Sure.
I think it's interesting because like for this part they give us the x, but like in the last part with the ratios, I think that's what they call it, that you don't actually like need the x. So well, like given the x like here.
Oh, and the other ones, they showed us what the divisor was, right? But they didn't tell us it was a 0. It could have been. Later, we're going to use a technique to figure out what are possible zeros, and then we got to just keep dividing until we find it.
Yeah, because they don't give us the zeros here.
Yeah, so right now they're going to give it to us, and it's not going to be too bad. But that doesn't mean they have to give it to us. Once you get to a quadratic form, you can just factor using your old techniques. So the goal is to go from whatever power you're at down to a 2. Once you get to a 2, use your whatever technique. You may have to do quadratic formula. You may have to do AC method. You may have to do just basic trial and error like this one. This one was nice. Doesn't matter. So now we have this guy factored into these 3 pieces. The question said, I forgot to mention, list all zeros. So to find the zeros, you would set this guy to 0, of course. Once it's factored, you can just solve it, right? So x plus 1 is 0, x plus 2 is 0, x plus 3 is 0, which means that x is -1, X is -2, X is -3. So just write your list in the solutions. Okay. Anyway, does the synthetic division part make sense? This last part is just algebra that we've done before. Do you see how we factored? That's the important part. Okay. That's pretty much it for synthetic. The next part, we're gonna have to figure out how do we find the list of possible zeros, and then we gotta factor. So eventually you're gonna be able to factor something without knowing what the zeros are. Although you could graph it and find the zero and then start with that to save time, but if you didn't have that ability, you'd have to create a list. So the next section is 3.4.
Well, when we're creating the list, like that X equals -1, -2, -3. And this might be a silly question, I don't know, but
Mhm.
does it matter if it has to be in curly brackets, or is it just for like
Oh,
a
well, no, it doesn't matter. In the homework,
or like,
the
when we do
brackets
it for the
means,
test,
um,
like on the test, are you gonna want us to write it, close it off a certain way?
it is more proper to have the brackets because this type of bracket denotes a set, and this is a set of solutions. Am I going to take out points if you don't put a set bracket? No, I'm not. But if you use it, it is more proper. It's kind of like commas and periods, right? Like
Yeah. Okay.
it'd be nice, but it's okay either way.
Okay. Thank you.
Yeah, let's move on to 3.4. Okay. And that sun setting is making it, whoops, worse. Okay.
They
The
someone got kicked out. They said they can't join. Something about the ID being invalid, the Zoom ID.
oh, that's weird. Should be valid.
It's Nathan Marin.
Hold on 1 second. I'll just message them and remind. Alrighty. So the fundamental theorem,
Thanks, Mr. Gonzalez.
yeah, no worries, of algebra. There you go. So whenever you see that in a math book, it's pretty important. There's one for calculus, one for algebra. There's many of them. So if f of x is a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. Okay. let P equal the factors or factor of the constant term and Q equal the factor of the leading coefficient the possible I wrote that all weird. The possible zeros of a polynomial will be all factors of P plus or minus P divided by all factors of plus or minus Q. Okay. So first example. Let's pick yeah, this one's more interesting. Okay.
3.4 is still locked.
Is it? Oh, let me see. Is it closed or is it just not in the modules?
It's there. Just when you click on it, it says that it's past due. The date.
Okay, let me fix the date then.
Is it for 3.4 or
34. Three, 2, and 3, 3. So I'm gonna change those. I'll change all of chapter 3 for you guys. We'll set that for the 10th for now.
yeah, I think it closed yesterday.
There we go. All right, it should be open. Just hit refresh.
It's open.
So can we usually get an extension or no?
What's up?
Can we usually get an extension or no?
Yeah, just let me know if you're a little behind. It's not a huge deal, but just send me an email or something. I've been extending them as we go so far. So all of chapter 3 has been extended because we're still at the beginning anyway. Okay. And I did extend, I think, chapter 1 and 2 a few times already. Find the rational zeros of f of x equal to x to the fourth, x minus x cubed plus x squared minus 3x minus 6.
Sir.
Mhm.
Why does it show that like on the first test grade, or why does it show that it only counts the final test as a grade?
We can talk about that after we finish.
Okay.
I'll look into it later. All right, possible zeros. So what you're gonna do is look at the factors of the constant and the factors of the leading coefficient, and then divide them. So all the factors of 6 would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. You agree that these are all the factors of 6, right?
Yeah.
Now the number in front is a 1. So there's only one way to get a 1. So the possible zero is going to be the combinations of these fractions. So 1 over 1, 2 over 1, 3 over 1, 6 over 1. But every combination of signs. So it's going to be, in this case, it's an easy one. 1 divided by 1 is 1. 2 divided by 1 is 3. And then 6. So these are all the possible zeros. So there are, in fact, 8 possibilities, right? So I'm going to do my synthetic division using those divisors. So I'm going to start with the 1 because it's easy. And then write this in there. So 4, 3, 2, 1, 0. So 1 minus 1, 1 minus 3 minus 6. So 1 times 1, 1. Negative 1 plus 1, 0. 1 times 0, 0. 1 plus 0, 1. 1 times 1, 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is a negative 2. This will be negative 8. It does not appear to be a 0, right? So let's try it again with negative 1. So 1 minus 1, 1 minus 3, 6. Bring down the 1. Negative 1 times 1. It's a negative 1. Negative 1 plus negative 1. Negative 1 times negative 2. Add these up. Negative 1 times 3 is a 0. Wait, hold on. Double check myself here. That should be minus. Yeah, there we go. Thought I missed something. Negative negative is 2. Negative 1, 3 is negative 3. Negative 1 times negative 6 is 6. 0. So we found a 0. So that means that f of x equal to x to the fourth minus x cubed plus x squared minus 3x minus 6 is equal to these. This will be the new result. X4 goes down by 1 power. All right, there we go. Then you add your new factor, x plus 1. So since it's a 0, then it is in fact a factor. But it's still cubic. So I need to test a few more until I get it down to a quadratic. And then I can use quadratic techniques. Any questions up to this point?
So, so the possible zeros is 3, or
All of these are possible. 1 minus 1, 2 minus 2, 3 minus 3, 6 minus 6. So I'm just
my question is like, since the original equation is the fourth power a, does that mean we're gonna find 4 zeros, or
not necessarily. At most we could have 4, but we could have 1 or 2 or 3 or none.
I guess we have to,
Um,
like test till we test all of them, I guess.
Yeah, we're not guaranteed 4 zeros, but according to the fundamental theorem of algebra, we are guaranteed 1 0 that is part of the complex numbers system, meaning it could be real or it could be imaginary. So we're guaranteed one of those types. That's about it. It's the only guarantee we got. And we also guaranteed to not have more than 4 because it's a degree 4. So now we're going to focus on this guy on the next page and then cycle through these possibilities. So this is the drawback of synthetic division. It's not too hard, but if you don't know what the zeros are, then you're going to have to guess, basically. Okay. So I'm going to try 2 now, I guess. Excuse me. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 3 times that, 3 plus 0 is 3. 2 times 3 is 6. Oh, cool. Got another one. So that means that f of x is equal to the original that we had was a cubic, right? And we had factored an x plus 1. Now we have factored another one. So this will turn into this 2 terms here. So it'll go down a power. So x squared plus 3 times x minus 2 times x plus 1. So since 2 worked, that means x minus 2 is a factor. Since negative 1 worked, x plus 1 is a factor.
I have a question.
Uh-huh.
So I guess like the first one we get, we then keep reducing the original from the original polynomial.
Right, that's what we're doing. We're taking the original and factoring it down to linear factors. This one is going to be a complex number. Let me read the question again. It said, find the rational zeros. Okay. So the only real zeros. So this is the factored form. The real zeros are x equal to 2 and negative 1. Now, if you were to graph this, you would see those zeros, hopefully. So the original was something. So here it is. Oops, did I mess up? That should be a 6, huh? Yeah, so we found a 0 of -1 and 2. There's only 2 real zeros. Although there
Right.
are 4 if you include the imaginary. Go ahead.
So I guess it's just easier to graph it.
Yeah, graphing it will tell you everything. But that's not what they asked. They want us to use synthetic to factor. So in your exam, you'll have to show all your work. You can graph it to check yourself. I don't care about that. But show your work. Okay, number 5 here. So this will be the same type of deal. Well, here they're only telling you, well, determine how many zeros there are. So you can find them and then just tell them, well, I found 3 of them. They're not even asking for what they are. They just want to know how many do you have. It's not always going to be 3, right? You could have less than 3. So that just happened to be that way. It is not guaranteed.
So
Like
we
this one,
basically-
this only has 1.
We basically have to do the process because it's not guaranteed.
I can't hear you.
We have to do the synthetic division because it's not guaranteed for the leading exponent.
Yeah, we need the synthetic to factor higher powered functions. Okay. So right here, they're just asking you, okay, what are the possible zeros? So I already showed you how to do that, right? So you look at the 16. What are all the factors of 16? Right, well, 1. And then you do the plus or minus 2, 4, 8, 16, right? Did I miss any?
And now I think so.
And then you do this coefficient. It's just a 1. So 1/1 is a 1. That's where they get this one. Minus the minus version, right? 1 over minus will be this one. 2/1 will be these two here. Just change the signs. So you just keep doing that, and then you get everything in the list. That's what we did on paper just a moment ago. Does that make sense? Factors of the
Yes.
constant, factors of the leading coefficient. So if you look at this one's more complicated because the numbers aren't as pretty. So this has a 2. So now the bottom, right? The bottom has plus or minus 1 and 2. So we're gonna have more combinations. And then you have 45, which will be 1. Okay, 1. What goes into 45? 3, right? 5. What else?
9.
9 for sure, yeah. 15. Did I miss any so far? 45. I don't think I missed any. So what you're gonna do now is do 1 divided by 1 to get the first two. 3 divided by 1 to get the second two. You see how it works? 5 divided by 1 gave these two. And then you do, after you do all of these divided by 1, which is this first set, you cycle through again and divide them by this one, the 2. So 1 divided by 2 is these two. 3 divided by 2, obviously, it's right here. And then so forth, all the way down to get the last set. So all of for this particular question, you have all these possible zeros. Does that make sense?
Yeah.
Can you find the list of possible zeros?
Yes.
All right. All right, cool. So it's not too bad, right? The annoying part would be, I mean, I wouldn't give you something like this on an exam, but on your homework, it might show up where they'll say, all right, we'll factor this completely. So you're gonna have to go through these until you find them. Although notice it's a power 4. So as soon as you find 2 of them, you can do quadratic formula. So just find like 2 of these and you'll be good. Okay. So the first couple, so those are just finding those possibilities. On this one, they want you to find the ones that are actually 0. So you write your list down and then you keep dividing until you find those 3 right there. So this is like the 3 that work with synthetic division. Same thing here.
So I guess it's a constant as there are 3 zeros.
What's that?
So I guess it's a consonant that it has 3 real zeros.
Sorry, you sound very far away.
Yeah, I guess. Can you hear me now?
Not really. Did you move your microphone or something?
And I'm using a laptop. Can you
Okay.
hear me?
Kinda, yeah, I can kind of hear you.
So I guess it's a consonant that there are 3 zeros.
Yeah, so you're not guaranteed 3, but you could have at most 3. So this tells you the maximum. But check this one out. This one has no real zeros, even though you have a cubic function. This one only has 2, and it's a cubic function. So you're not guaranteed the maximum. Okay. So let's do, I don't know, let's do, I guess 14. Find all real zeros of x cubed minus 13x plus 12. Okay. So first thing we should do is find the possible. So the factors of 12 go on top. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And then you divide by that factor, so it's just a 1, so that'll be pretty easy. That's good. Also, since it's a cubic, once I find one of them, I can do just basic factoring. So I'm going to start with 1, I guess. So I have 3, but no 2, so I've got to put a 0 there. One times 1. 1 times 1. 1 times that. Cool, got a 0. So now this will factor into x squared plus x minus 12 times x minus 1. This minus 1 is coming from this opposite, right? So now just factor this with trial and error, the factoring techniques from, basic algebra here. Plus 4 minus 3. So there's the 3 factors. So x, the zeros, right, would be 1, 3, and negative 4. And that's how they got these answers here. That makes sense?
Yes, it does.
Are there any questions on how this works? Is it making sense? It's not too bad, I hope. Just let me know if you're struggling or if it doesn't make sense.
What about 18? Or what do you have for 18?
Oh yeah, let's do that one. That was kind of weird. They gave us a a 0 for 2. Oh, okay. So this one they're working in reverse. They're telling us find the polynomial with these real coefficients. With real coefficients given these zeros, sorry. So yeah, good question. Example 3. Is it 3 or 2? 2, 3, 4. Yeah. Find the polynomial function with real coefficients that has the given zeros. Okay, so remember we said if something is a 0, right, that means that f of 2 is equal to 0 and f of negative 3i is equal to 0. That means that there is a factor x minus 2, right? And there's going to be a factor for this guy, x minus negative 3i. And all the complex numbers come in pairs. So it'll be x plus 3i for the other one. Oh, sorry, minus. Minus. So let me make you a note real quick. If AI, no, how should I write this? A plus BI. I think that's how we put the notation we use. A plus BI is a 0. Then A minus BI is also a 0. So if this is a 0, then so is this. They didn't tell us this, but that's a fact that we should know. So that would mean that we have x minus 2, x plus 3i, x minus 3i as my zeros. So I've basically found my, they look like lowercase lambdas. Let me fix that. There we go. I found my polynomial using this fact that 2 is a 0 and minus 3i is a 0. So multiply all this garbage and you're going to get the answer that they're looking for. So these are difference of squares, right? Conjugate pairs. So that will become x squared minus 3i squared. Or you can just FOIL everything out and you'll end up with this. It's up to you. I'm just trying to show you a shortcut. This is a conjugate. So they multiply it into the first term squared minus the second term squared.
I have a question.
Uh-huh.
What does the real coefficients mean?
Meaning that once it's all said and done, there's no more imaginary components. Like there's all the numbers on the x's are real. So this will become 9i squared, right? This will be plus 9. Well, I mean, I shouldn't skip steps. This would be minus 9 times negative 1, because we said that I squared is negative 1. So finally, we get negative 9 times negative 1, so x squared plus 9. Now notice they're all real numbers now. No more imaginary pieces. So multiply this out, so that'll be x cubed plus 9x minus 2x squared minus 18. So this is the function that they want. Nothing but real numbers. So the first step is the theory. So you need to understand that if something is a 0, then it's a factor. If you have an imaginary part, then it's also a 0, same rule, but they come in pairs. And then after that, you just do multiplication. I showed extra steps so you can see the multiplication. Is there any questions on this guy?
No, but thank you. That helps.
Let me start off the next one for you so you can see if these three are zeros, then that means f of x would be equal to x minus They wrote 3 twice. You see that? That must mean that it is a square. One plus I means it has to come in a pair. So 1 plus I times 1 minus I. So using the factor theorem, if something is a 0, then they are factors. So this would be the setup, and then multiply all this garbage and you'll get these terms eventually. But this is the important part. Do you see how we set that up?
Okay, so we multiply and then we get that polynomial.
Yeah, you multiply everything, you won't have any more i's, and you'll get this.
Do we have to memorize the cubic formula or difference of cubes?
No, you don't have to memorize anything. Just make sure you know how to use them. I would make a formula page if I were you, just for each exam. Let's see here. So in this one, it's the same thing, except you have to solve for a. So degree 4, meaning it's a 4th power function with these zeros. So f. So what you do on this one is you don't know what's in front. So just say there's some a over here. I don't know what it is. So then you do the factors like we did before. So x minus minus 2, so plus x plus 1 is a 0, so x minus 1 is a factor. I is a 0, so then that means x minus I is a factor, and then I have to write its pair, x plus I.
So we don't use the coefficient of the first one, of the leading one. I guess so.
Coefficient?
The one of the lead, like the 4x to the 4th power, we don't use the 4.
Well, we got to find this number. So this is telling us that it should have 4 factors because degree 4. So we have 1, 2, 3, 4 factors. We're going to multiply all that garbage out and we'll have our answer. But before you do that, plug in the 0 and set it equal to -8, and then you'll find the a. Once you find the a, you're done. Just multiply it out and you'll get this. Oh, oops. You get this guy. So f of 0 is -8. So you would get 2 times -1 times -I times a equal to -8. But other than that, it's the same exact thing we just did. Does that make sense or no?
So what would be when we multiply -I times I?
-I times I would be -I squared, which would be -1. Okay. Let me see where we are on the syllabus. Yeah, yeah, I'll do that. Sure. Okay. So we just finished 3-4. So 4-1 and 4-2, I think I'll say for Thursday. So the first exam covering everything up until now is coming up. So what I'm going to do is review next week and then do these 2 sections. So I'm going to give you all the way until, I think I already told you the date. I don't remember what it was. But that's what we're going to do next week. So we'll review and we'll do 1-8, 2.6. Thursday, we do 4-1 and 4-2. Okay. And I'll extend all of chapter 4 as well. Yeah, 17th. So next week is review. So 17th is when you should be taking it. We'll try your best to get caught up if you aren't already, because exams coming up in about 2 weeks, or less than 2 weeks.
Sir, what percentage of that exam, or what's the percentage that it's worth? So then the final exam is worth like 65%.
No, that shouldn't be right. But whatever the syllabus says is what we're gonna do.
Yeah, because
Oh.
on the grades it says the final exam is worth 65% of the grade.
Yeah, I don't think I've gotten around to fixing those weights. I'll do that very soon.
Okay.
I thought I had, but guess not.
So what are the stuff that will be graded?
So let's look at our syllabus here.
You're not sharing your screen.
Hold on a moment. Where is it? Here we go. So 60% is all the exams put together. 20% is the final. 20% is your homework.
Okay.
It might not be reflected in your current grade book, but I'll fix that very soon. But this is what it's going to be.
Okay.
All right. Well, we'll stop here. If you guys have any questions or concerns, feel free to stay. If not, I'll see you Thursday for